Math 2, Unit 6, Similarity. Turn the page to the back of the objective sheet. We will start with similar triangles. All right, we've studied congruent triangles. Congruent triangles mean the same size and the same shape. Similar triangles mean just the same shape. All right, so you see these two triangles. They are similar triangles. They're the same shape, but hopefully it's clear this one is bigger. But I think you guys can see they're the same shape. We're pretty good at picking those things up. What does it mean to be similar, to be the same shape but different sizes? Well, that's what we're going to be talking about the next 2 weeks. So we will be spending most of our time talking about triangles, but really this stuff is true for all polygons. So number 1 up there, it says polygons with the same shape. I believe that's supposed to be shape. Change that R to a P. Polygons with the same shape but different sizes. All right, number 1, corresponding angles are congruent. So let's fill that in. Corresponding angles are congruent. All right, so let's go ahead and name these triangles here. Let's call this triangle ABC, and we'll call this triangle DEF. Okay? So did you name your triangles? All right, so corresponding angles are congruent. Well, if triangle ABC is similar, that's the notation we use for similar. If triangle ABC is similar to triangle DEF, that means that angle A and D are congruent, and I think those are probably right angles, so we'll mark those as right angles. And that would mean angle B is congruent to angle E. So we'll put one of our congruency lines there. And angle C is congruent to angle F. So everybody got that? And we can go a step further, and let's write over here, let's put angle A is congruent to angle D. Angle B is congruent to angle E. And angle C is congruent to angle F. Corresponding angles are congruent in similar triangles. So the angles are the same size. Okay, one time when we talked about that last unit, I talked about equilateral triangle. And we know equilateral triangles have equal angles, right? So 60, 60, 60. And if we drew another equilateral triangle right around it, it's pretty easy to see that those angles all had to be 60 also, because that's an equilateral triangle, which we know has 3 60-degree angles. And this guy is an equilateral triangle, which means it has to have 3 60-degree angles. So clearly these two guys are the same shape, just different sizes, and hopefully it should be clear that they have congruent angles, right? Okay, number 2. Corresponding sides are proportional. Let's write that down, then I'll explain it. Corresponding sides sides are corresponding sides are proportional. Okay, so what does that mean? It means the difference in the lengths of the corresponding sides will be an equal difference. Meaning if we said that triangle ABC had side lengths of 3, 4, and 5, then triangle DEF would have to have sides something to this effect, maybe 6, 8, and 10. Proportional means that side AB over side DE would be equal to side BC over side EF, which would be equal to side CA over side FD. And let's look at those comparisons. So that means 3 over 6 should equal 5 over 10, which should equal 4 over 8. Do those three fractions equal each other? Yeah, because when we reduce, they all reduce to 1/2, don't they? All right. Well, the reduced ratio is called the scale factor. So let's write that in as a number 3. Scale factor, okay? That is the ratio of the lengths of the sides in similar polygons. Okay, the scale factor is the ratio of the lengths of the sides in similar polygons. Always reduced. The scale factor is always the reduced ratio. Makes sense so far? How are we feeling about all the information I've given you so far? Okay? All right, then let's go down and put some of it into use. All right, so we have triangle JKL is similar to triangle PMN. To identify the corresponding congruent angles and write a proportion with the sides. All right, so pretty easy. Here they're telling us that these two guys are going to be similar, which means angle J has to be congruent to angle P. So we will just put a congruency line there. And angle K has to be congruent to angle M. So we'll use 2 lines to show that. And finally, angle L is congruent to angle N. So clearly in this first example, the triangles are not in the they're kind of rotated and spun around, and that's what's going to happen on most problems you do in this unit. They're not going to sit them nice and, just perfect for you like that. Sometimes it'll be like that, but most often, just to make sure you know what you're doing, we're going to spin those things around, flip them over, and make you work for it a little bit. But we know angle J is congruent to angle P. We know that angle K is congruent to angle M, and angle L is congruent to angle N. So all we did here really is just rotate this guy 90 degrees, didn't we? Okay, so the other thing we have to do is write a proportion statement, okay, or show that the sides are proportional. It's pretty easy. We want to say that JK over PM, so let's write that, JK over PM, that ratio should equal KL over MN, which should equal LJ over NP. Okay, this is a proportional statement. We're saying that this side should be congruent, or excuse me, this side divided by this side should equal this side divided by that side. All right? And if we had some numbers to put in there, it would make a little more sense. All right, how we doing? All right, let's move on to number 2 here. Now we'll actually solve for some variables. All right, so let's take a look at our congruency, our similarity statement. DE is proportional to HJ. So let's write that down. In our proportional statement, it's DE divided by HJ should equal EF divided by JG, which should equal FD divided by GH. Okay, and I got all that information from this similarity statement. DE divided by HJ should equal EF divided by JG, which should equal FD divided by GH. I wrote those 3 ratios. All right, now let's put some numbers with them. DE is 9, HJ is 15. So 9 over 15 should equal 14 over Y. And FD, 12, should over GH, which is X. All right, so when we're solving one of your ratios in the proportion, we have to have the both numbers. We have to know. So let's go ahead and find the scale factor. What's the scale factor in this problem? 3/5, right? Because 3 goes into 9 3 times and 3 goes into 15 5 times. So 3/5 is our scale factor. All right? So we can use our scale factor to solve for X and solve for Y. Let's go ahead and solve for Y first. We're just going to cross multiply here. 3 times Y is 3Y. 5 times 14 is 70. And if we divide both sides by 3, we end up with Y equals 23.3. We'll just round off 23.3. Whenever I end up with a decimal in Math 2, I always go back and check my work just to make sure I did it right, and I did. Okay, so we know X is equal to 23.3. Let's go ahead and solve for Y now. Or excuse me, Y equals 23.3. Let's solve for X. We use our scale factor again. So we'll go 3/5 equals 12 over X. Again, we cross multiply. 3 times X is 3X. 5 times 12 is 60. Divide both sides by 3 and we get X equals 20. How we doing on those two? Make pretty good sense? Okay. So flip it over. Let's do a few more. All right. So these really aren't numbered. I think this is number 3. So in number 3, if these two triangles are going to be similar, if triangle XYZ is similar to triangle RYS, then those two guys, RS and XZ, are going to have to be parallel. So identify the corresponding congruent angles. So let's start there. Well, it's pretty clear they both have a Y, don't they? So it is clear that angle Y is congruent to angle Y. We know that because of reflexive property. And let's see what else we know. We also know that angle X is congruent to angle R. And if these two guys are parallel, we know that by when lines are parallel, corresponding angles are congruent, aren't they? And which gives us also that angle Z is congruent to angle S. And same reason there, when lines are parallel, corresponding angles are congruent. Okay, and our first, we're not going to talk about it today, but our first way to prove similar triangles is by angle, angle, angle. So we know that these two triangles are similar because of angle, angle, angle postulate. So we know that triangle XYZ is similar to triangle RYS. Okay, now the next thing they want us to do is write a proportion with the sides. So we'll say that XY over RY should equal YZ over YS, which should equal ZX over SR. Okay? Does that make sense to everybody? So we're saying that obviously Y is equal to itself, that angle X is congruent to angle R, and that angle Z is got to be congruent to angle S. All right, moving on to number 4. So triangle ABC is similar to triangle DEF. Solve for the variables. All right, so let's start by writing our our proportional statement of the sides. So that means AB over DE should equal BC over EF, which should equal CA over FD. Is there any questions on how I'm coming up with those proportional statements? I'm just using the similarity statement AB over DE equals BC over EF, which equals CA over FD. And now we can actually fill in what we know. AB is 25. DE is X, BC is 20, EF is 28, and let's see here. I guess that's all we have. That's all the information we have. So it looks like all we need to do is find X. Now, we can do it like this, just get 20X and multiply 25 times 28, which would be fine. But the scale factor is always helpful. So let's find the scale factor. What number will go into both 20 and 28 evenly? 2 would work, but how about 4? So 4 goes into 25 times, and 4 goes into 28 7 times. So always a good idea to find your scale factor first. So now we can go 25 over X equals 5/7. Guys, remember, one fraction in a proportion is called a ratio, and the whole thing, when you have two fractions equal to each other, is called a proportion. So we'll cross multiply. X times 5 is 5x, and 7 times 25 is 175. Divide both sides by 5, and we get x equals 35. And just a quick check of that, if you go, okay, BC is related to EF, so 20 to 28, 25 to 35. It makes sense, doesn't it? If we just set that up a little bit, 25 over 35 should equal 20 over 28. The numbers kind of make sense, don't they? 25 gets bigger, 20 gets bigger. All right, moving on, number 4. No, that's actually number 5. Let's go a little quicker. All right, so these are the two that we know in each. So let's just see what we need. So AG over KX should equal GM over XD. Okay, I found the ones I needed. AG over KX equals GM over XD. And when we plug in the information, what we end up with is 32 over x plus 3 equals 36 over x plus 6. All right. Now, we ready to cross multiply? 32 times x is 32x. 32 times 6 is what we get, 12, carry the 1, 18, 19, 192. And that should equal 36 times x plus 36 times 3, which is 108, if I'm not mistaken. Can you guys see that? I know it's getting a little small there. I don't know if that helps. But if we subtract 32x from both sides, and if we subtract 108 from both sides, you guys are writing a little bigger than me. The 32x goes away over here, and the 108 goes over there. And what we end up with is, what, 94? No, 84 on this side and 4x on this side. Divide both sides by 4, and we get x equals 21. Okay, moving on to number 6. All right, let's look at the information we have. So let's see. Let's go TL over CH equals LY over HK. And let's see if that gives us enough information. So that would be 25 over 10 equals 4x minus 1 over x plus 5. Now I'm going to double check. I went a little fast. TL over CH equals LY over HK. And then TL over CH equals LY over HK. Okay, looks good. So again, probably the easiest thing to do is to reduce to our scale factor. So 5 goes into 25 5 times, and 5 goes into 10 twice. So let's cross multiply using our scale factor. So that means 2 times 4x is 8x. 2 times -1 is -2. And that should equal 5 times x, which is 5x, and 5 times 5, which is 25. I'm going to subtract 5x from both sides. That goes away. I'm going to add 2 to both sides. That goes away. I end up with 8 minus 5 is 3x on this side. Equal sign comes down. 25 plus 2 is 27. Divide both sides by 3, and we get x equals 9. All right. Number 7 and 8. Why don't you guys go ahead and work on those? Yes.
Peace.
Peace out.
You have tissues.
Check that cabinet right there. Okay, take a look at my work for number 7 and 8. Hopefully yours matches. Any questions? Okay, now a big mistake everybody makes here on this one is you have KNM and you have KLJ. So a lot of people, when they set up this ratio of KN to KL, they usually make the mistake of going 12 over 20. Okay, instead of going 12 over 12 plus 20. Be very careful on that. Any questions on 7 or 8? Yes.
Isn't it K all over K?
You did what?
K all over K.
Yeah, K. Oh, it doesn't really matter. Oh, okay, yeah, they were backwards. You know, I didn't look at the similarities when I did it, but I just went this one over this one.
Yeah.
So yeah, you're right. I looked at them kind of backwards, but it really doesn't matter. You can flip a ratio and it's the same thing. All right, so your job today is to do the first page of worksheet 3.1, which is 1 through 12. 1 through 12.